Topic today is effectiveness of fuel treatments in mitigating wildfire severity, lessons from large wildfire events in the interior of the Pacific Northwest. This webinar is part of our BC Regional Adaptation Collaborative series. And so BC Regional Adaptation Collaborative is all about supporting local governments and First Nations and private organizations in thinking about future climate and building that into their plans and decisions. You can check out our website if you're interested at retooling.ca, and there's a database of resources there and links to various tools. If you aren't already on our email list, you can subscribe. On the website, there's also recordings of past webinars. So a recording of this webinar will be up in the next week or so, as well as a PDF of the slides for you to be able to view. We'll let you know about that. And this program is managed by the Fraser Basin Council. We're a nonprofit organization with a mandate for advancing sustainability across British Columbia. And we're pleased to have the support of Natural Resources Canada, the BC Ministry of Environment, Climate Change Strategy, BC Ministry of Forest Lands, Natural Resource Operations and Rural Development, and many others providing in-kind support. We also just wanted to flag for folks the upcoming Adaptation Canada 2020 conference, which is coming to Vancouver in February. And oh dear, little technical difficulty there. So Adaptation Canada is coming to Vancouver in 2020, which Fraser Basin Council will be hosting. And thanks. If you're interested, feel free to sign up for updates there or check out information on our website, and we'll also put a link in the chat box when we're done here. Just a few logistical items before we get started. We'll be keeping our audio muted for participants just so that you can hear our presenter today. You will be able to ask questions, of course, and using the question box feature. And if you have any technical difficulties, you can email my colleague Cherry Tam at fraserbasin@gmail.com, and she'll help you out. As well, we'll get to the questions at the end of the presentation, but feel free to ask questions while we're going. And so we're really pleased to have Susan Prichard join us today. She's a research scientist with the School of Environmental and Forest Sciences at University of Washington. And she studies fire ecology, landscape vegetation, fire dynamics, fuel, fire management. And her main interests are in the effects of fire and other disturbances on forest dynamics, climatic change on forest ecosystems, and fuel treatments to options to mitigate wildfire effects. So we're going to learn a bit about some of her research results, and if you'll just bear with us for a second, I will pass the controls over to her.
Hello everyone, my name is Susan Prichard, and I'm really pleased to be speaking with you today. It would be preferable to all be in the same room, but we will make do with a webinar, and I look forward to your questions as we move through the presentation. So even though my title says that I'm a University of Washington employee, I've actually lived in North Central Washington State for the past 15 years. It ended up being almost too good of a place to study wildfires, as we'll get into in a little bit. We've had a lot of wildfires in our area, and so effectively I've been trying to learn from them while also being embedded in a community that's really recovering from a lot of wildfire events and grappling with what it means to move forward in a warmer, drier world in our area. So as many of you guys, I think, recognize, because we've been sharing smoke and sharing some wildfires across the US and Canada border, wildfires recognize no border. And indeed, we've sent our fair share of smoke to BC and then received quite a bit from you in the last 2 years. We also, not jokingly, have just felt the pain of the last two summers in BC. Those were unprecedented wildfire events, and I get it, and I think a lot of our community in North Central Washington feels that very much for you. So as I move forward with some research results, I want to also let you know that I'm very emotionally invested in wildfires, and I get that they're hard and difficult. It's, as some colleagues mentioned in presentations, it's a wicked problem. So I'll just show a little bit about the context for wildfires and what I've been studying. So the orange area is Winthrop, Washington again, and we can ignore the kind of back map. We're now just in North Central Washington here. And what I wanted to point out is that we've just had a huge number of large wildfire events. So just right center here is the Carlton Complex fire, which remains the largest single wildfire event in Washington state history at around 100,000 hectares. And then we had even larger wildfire events that are in kind of this pink color, a dusty pink color in 2015. So one of the striking things about all of these kind of fires as they bump into one another is that they've been happening mostly in the middle of hot, dry summers and burning at really high severity, meaning that a lot of the trees have died where they do burn in forest areas. And so these landscapes are starting over, and there's a lot of new tree regeneration, hopefully, in these areas. So in contrast, back when a lot of people were growing up in the Methow Valley where I live near Winthrop and elsewhere, fire wasn't common for the last 100 years. The 1970 Forks fire was an unusual event at around 2,500 hectares in size, made the front page of the Seattle Times at the time because it was a big deal. We know now that the lack of fire, the absence of fire, was unusual through these landscapes over many millennia, but for the last 100 years, this area didn't have a lot of fires until about 20 years ago started. And so one of the things that I've been most concerned about the type of fires that we're getting are that, excuse me, I'm just going to try to close a few. No, we're good. So as these fires have been burning, many of them are what we would call stand replacement events. And I have this chalkboard. It's a little bit hokey, but it's to remind me to say that we think of these stand replacing fires as clearing the slate. And our concern as ecologists about them is that as wildfires burn at high severity, leaving very few trees left that are still living, that might really accelerate the landscape response to climate change. We're getting much hotter and drier summers, and so there is some real concern about, especially at lower elevations where we have ponderosa pine and Douglas fir dominated forests, that we might actually not have regeneration in some of these landscapes. This particular picture was taken in the Upper Finley Canyon outside of Winthrop, and the canyon is probably about 5,000 hectares in size, and you can see that there's not a stick of living tree here. We actually had major slope failures following the wildfire event, and to date, the ponderosa pine in this system isn't showing much sign of regenerating on its own. So this is a big concern when we're talking about ponderosa pine and Douglas fir. As both species get older, they have a lot of built-in inertia. They are built to last. So once they're deeply rooted, they have thick bark and pretty drought-tolerant foliage. So they're resilient to climatic extremes. They can handle a lot of hot, dry temperatures in the summer once they're mature. And they're also really adapted to frequent fire. Here's this, I call it a charismatic megaflora. Ponderosa pine looking really good. It's got its crown probably starts easily 30 meters up in the canopy. So it would be pretty resilient to a lot of surface fires. And then the bark is thick, and so even a kind of pretty good intensity surface fire couldn't get it. However, with a lot of stand replacement, we don't have resilient seedlings. So this ends up being the most vulnerable phase of a plant's life. Here's a Douglas fir seedling. Has just very low little bit of carbohydrate reserves in its tiny seed, shallow root systems, new leaves that are not necessarily drought tolerant. So we have a lot of seedlings raining down on these post-fire mineral soils, and not many of them necessarily make it. It's a hard time of a tree's life, and that's why we're concerned that with a lot of areas of synchronized stand replacement, we might have some responses to these warmer, drier summers in terms of regeneration failure. Another aspect of resilience can be viewed when we zoom out. So this is a repeat photography taken near Wenatchee, Washington. The top photo is pretty recent, and it shows pretty continuous forests of ponderosa pine and especially Douglas fir. You can even see on the top photo there's a little red on this southwest facing slope. That's actually western spruce budworm. And if you look down at a 1930s photo taken from the same fire lookout, you'll see that those slopes on the southwest facing slopes were open. And so we feel like those Douglas fir that have been managing to fill in are a lot more, they're growing on kind of marginal sites, and they're more susceptible to insect and outbreak for sure. But they're also kind of filling in this landscaping, making the entire landscape more susceptible to a free-running crown fire over a large landscape. And so we also talk about this kind of contagion at local scale. So if we were to take a hike anywhere around north central Washington, and I'm sure that this is familiar for a lot of folks in southeastern BC, we would see these old ponderosa pine trees, sometimes old Douglas fir trees, that are kind of the backbone of a previously fire-maintained forest. And now it's filled in with a lot of Douglas fir or potentially grand fir in some locations. So this state of a lot of infilling, I'm sure this is super familiar to a lot of you, it makes these large trees vulnerable. So all of the moderate-sized trees, the dead wood, the litter on the forest floor, can lead to big fire, fire that not only runs on the surface of these forests, but also can ladder up through these intermediate-sized trees and burn the crowns. So we kind of have this perfect, or maybe we should say imperfect storm of a lot of fire exclusion. And I'd love to get into more about the factors behind the fire exclusion. It's certainly not just Smokey the Bear. It's cessation of aberrational or First Nations burning, as you might say, as well as fire exclusion through cattle grazing. There's so many factors. I don't have a lot of time to go through them. But in general, we just have a lot more landscapes vulnerable to burning. And at the same time, we're getting these warmer, drier summers that are leading to a greater chance of burning. So this image is not perfect, but I had a better one that just showed the United States, and I didn't want to do that for this presentation. So this is Don Falk's work projecting increases in the area of burned. And you can see that Western United States and especially the kind of southern portion of Western Canada have a lot more projected area burned. And sure enough, the 2017 and 2018 wildfire seasons of British Columbia are pretty ominous. So, that is kind of the doom and gloom portion of my presentation. I'm a stubborn optimist. I think you have to be for studying climate change for 20 years and continuing to. But I wanted to share this graphic here as something where I think it's actually unfair to just say that everything's going to be on fire and we can just expect more and more areas to burn. And the reason why I'm saying this is that climate is not the only thing driving these wildfires. So I have this kind of complicated set of images as well as graphics here to kind of illustrate a point. And so on the very left side, we have some areas in the world that are more climate limited. So I know some of you are from Vancouver, BC, where you have live within temperate rainforests. Plenty of fuels on the ground, from the litter layer to live mosses and shrubs and other herbs, all the way up to a multi-layered older forest canopy. plenty of fuels to burn, plenty of ladder fuels to carry fire, but in most summers, typical summers are just too moist. And so the climate limiting aspect of rainforests is that they're generally too moist to have fires, lightning strikes catch hold and start a burn or a human ignition. Boreal forests often work the same way. And then on the opposite side, we have areas that are plenty dry to burn. So a lot of our arid grasslands and deserts, any day that a lightning strike might occur, the fuels would be quite ready to burn, but they lack continuity. So you might have a fire start, but there are simply not enough fuels to carry fuel across the landscape or fire across the landscape. And then in the middle, we kind of have the sweet spot, and that's where this graph comes in. You can see that this red line shows pretty low fire currents in both the temperate and tropical rainforest systems as well as desert systems for different reasons. And then in the middle, we kind of have the Goldilocks situation of just right for a lot of fire. So our mixed conifer forests of a variety of kinds in Western North America fit with this. And the hopeful, the kind of stubbornly hopeful message that I'm hoping that will be relayed in this presentation is that we're working on kind of hopefully mitigating climate change, but that's kind of a slow and kind of scary bus to slow down. But what we can do in the short term is really start mitigating the fuel condition and making our understories of some of the forests, especially ponderosa pine and Douglas fir forests, less susceptible to fire, so more desert-like in the understory so they won't carry fire. All right, so with that, we have our first set of questions, and I think Jim was going to have me read them off, and so the answers will be slightly different because I was a bit too wordy with my answers here. So you'll see on your poll these questions. So the first one is, what is your opinion about fire and fuels management in British Columbia? So the first answer might be no changes are needed. The current fire and fuels management is appropriate. Second one is active fuels reduction and prescribed burning is needed in my area. Third is fuels reduction is needed, but prescribed fire smoke is unacceptable. And then finally, on logging slash, there's a lot of timber harvest areas in both Washington and British Columbia. So a question would be, logging slash must be removed or burned to reduce fire hazard.
Okay, so looks like most people have responded now. So we're just going to close it and I'll share the results. So almost nobody thinks that no changes are needed, about 2%. The active fuels reduction and prescribed burning is needed. 89% of people agree with that. 48% agree that logging slash must be removed or burned to reduce fire hazard. And 14% people agree with needing to reduce fuel, but prescribed fire smoke is unacceptable. So,
all right. Just a note on the prescribed fire smoke is unacceptable. I would almost expect 30% to respond that way because throughout Western North America, at least, about 30% of households have someone that lives within that household that is has health issues regarding smoke, whether it's asthma or heart conditions. So completely understandable that prescribed fire smoke would be unacceptable, and it's part of our wicked problem. So, all right, well, what I'm going to do in these next sections is continue on with the fact that I've lived amongst a lot of wildfires and have had the opportunity to learn from them. And so I'm going to move through, hopefully quickly, 4 lessons that I've learned by studying wildfires in our area that hopefully will have some application in British Columbia and beyond, in Canada as well. So the first one is that fuel reduction treatments, including past wildfires, often mitigate the severity of subsequent wildfires. Second one, it's a bit of humble pie. We've had some wildfires hit during really extreme fire events that test the limits of fuel treatment effectiveness. So I'd like to share those lessons. And then third, we've been really interested in studying this idea of the lack of fire on landscapes and how that leads to a lot of contagion on those systems, both to insects and disease, but also to fire. So we wanted to do some simulation modeling to try to bring back fire in a way that doesn't actually produce any smoke for any of us because it's a modeling exercise. So I'll share those results. And then finally, lesson 4, because I'm embedded in a fire-prone landscape, I'm really interested in how our community can start building resilience to wildfire and how these field treatments might assist with that as well. All right, so on to lesson 1. In this study, I looked at a 2006 tripod fire that burned just north of Winthrop, Washington. At the time, it was the second largest wildfire event in Washington state history at around 80,000 hectares in size. And this is just one of the success stories within it. There were many. The photo on the top right shows the interior of a Douglas fir forest that had been thinned and prescribed burned about 2 years prior to the wildfire. And it stood the test. So at the base of the unit, in the below slope, there was actually active crown fire and then a hot surface fire both coming up into the unit. And the fuels, much like a desert, were too discontinuous to allow fire spread into this unit. And so when we were actually doing the burn severity sampling, monitoring, we felt like we were actually monitoring the prescribed fire effects rather than a wildfire, because this unit was a complete barrier to spread. And so this just shows a little bit more on the tripod complex. The colorful image is a burned area reflectance classification image that is taken, or calculated really, from a pre-burn Landsat TM image and a post-burn Landsat TM image, and it shows a difference in reflectance. So areas with high reflectance are where the forest cover has been pretty much removed from a fire, and the soils are also bare from the fire, and so those reflect the most. That's shown in red, and then moderate severity also has a lot of tree mortality associated with it. That's an orange. Low severity would be more of an underburn, where a lot of the trees survive. And then there's unburned, where these are patches where the fire just didn't actually burn. Many of them are kind of higher elevation meadows in this case. So what you'll, I think, will notice from this image is that we had a lot of high severity in this fire. The gray patches are previous wildfires. One of them was 1970, which was kind of surprising. Lodgepole pine-dominated area that just wasn't ready to burn yet. It didn't have enough on the surface fuels to catch fire. Similarly, a 1994 Thunder Mountain fire, I remember I can use my mouse here, was mostly a complete barrier to fire. 2003 Fair Wildfire was as well. I have the dialog box is kind of in front of me here. I'm going to move it. So anyway, a lot of these past fires were barriers. And then this hatching at the kind of southern end of the tripod complex shows past field treatments. And I just kind of clipped these to be within a kilometer of the fire area. And as we zoom into the area right here, we can see that there's these old clear-cut and thinning blocks that actually really look kind of intriguing. And what we found in kind of related studies is that the old clear cuts that had been mostly prescribed burns were virtually green islands amongst the sea of stand replacement. And that really motivated our study. I actually did a field-based study, and so our 3 treatments that we evaluated were control, where there was no management, thin-only units, where thinning had been done and the Forest Service, local Forest Service, was going to prescribe burn, but these sites hadn't been prescribed burned yet. And then finally, thinning followed by prescribed burning. And this ended up being kind of one of the most satisfying statistical analyses I've ever done, because the results were so clear. When I considered all trees, including even small trees, what we found was there was no difference between unmanaged controls and the thin-only in terms of how many trees survived. Both of them had really low survivorship, whereas thin and prescribed burning had higher survivorship, about 50%. And then when we considered larger diameter trees, so 20 centimeters and greater, it was even better for the prescribed burn sites, where over 75% of the trees survived. And again, no significant difference between the control and thin-only units. And so what that tells us is that thinning only can work, but to really hedge your bets on mitigating future fire severity, thinning and prescribed burning really is effective. We found that not only in the tripod, but other areas as well. So I hinted that there would be a bit of humble pie. So that study was completed around 2009, and I honestly thought that the tripod fire, which occurred in 2006, would be the largest wildfire that I would study in my career in my area. But lo and behold, 8 years later, we had the 2014 complex. And this fire, I'll get into in the next slide, was completely different in a lot of ways. Its final size was larger than the tripod fire. So the tripod was right around 80,000 hectares, and this was over 100,000 hectares. It also had in there a lot of areas that weren't forested, so it burned through a lot of shrub steppe. 37% of the landscape was forested. It was a big deal fire. You can see that 310 homes in our community were burned by this fire, and it really did burn through our main valley called the Meta Valley. And so one of the main reasons why the Carlton Complex burned so differently than the tripod was that we had a big, large fire spread event. So these progressions are a bit confusing to go through, but a yellow shows kind of early fire starts in both the southern part near the town of Carlton and then a northern part in Winthrop. And on July 17th, we had strong, sustained winds, as well as almost record-setting temperatures and low relative humidities. And these wildfire starts, which started out kind of small and were definitely actively being suppressed, exploded. And so in a single day of July 17th, these fires burned about 167, well, I'll move it, I'm converting on the fly from acres to hectares for everyone. They burned about 70,000 hectares, so they were almost the size of the tripod in a single day event. And correspondingly, we now have the burn severity map on the right showing a lot of areas of high severity or moderate severity, so a lot of areas of stand replacement from this really wind-driven, crazy fire event for our communities. So it took me a little while to kind of collect myself and want to study this fire. Actually, it was quite the big event for us. But I did pursue research funding, and I really was interested in looking at how field treatments weathered the severe fire weather. So here we have some kind of graphs that again show severity in terms of red is high severity and green is unburned, with orange and yellow in the middle. And I parsed out field treatments that were burned in that early kind of crazy July 17th progression and the adjoining days, and then less severe fire weather. What we see over here is we have 5 different treatment units that were summarized for this analysis. The first is clear cutting and prescribed burning. These were some older units and they did not fare well. Prescribed kind of landscape burns had some survivorship. Thin only treatments didn't work very well. Thin and pile burn treatments were abysmal in this case. And then thin and prescribed burning did fairly well. You know, they still had about 55% mortality, so that's not great, but they were the best of these units. And then interestingly, when we look at less severe wildfire weather, where there weren't the strong winds driving fire, all treatments worked pretty well. We still had a little bit better effectiveness with thin and prescribed burning, but honestly, the thin-only units worked pretty well as well. So that's what we found out from the Carlton Complex. There's a lot more, but I was just trying to be short about it. We also summarized all of the past wildfires that were burned in the Carlton Complex and looked at time since fire and how much of the area burned as stand replacement within these past wildfires. And what we found was not surprising, was a pretty strong relationship with really recent burns burned at they were either unburned or had low severity, but the farther out in time that you got, the less effective they were. So it just kind of shows that, you know, burning really is effective at mitigating fire severity, but it only lasts for a certain amount of time. So Right, we're going to move into our next lesson. This is the modeling exercise, and I figured it might be a nice time for yet another poll. I'd love to hear your kind of thoughts about the role of fire in landscapes. And so the question here is, what is your opinion about the role of fire in British Columbia? And the three responses are, fire suppression is essential to protect communities and forest lands. Second is, we need to use prescribed fire as a tool to reduce fire hazard. And then finally, some wildfires should be allowed to burn to restore the role of fire.
Yeah, the poll is open, so we'll give folks a little bit of time to fill it out and then share the results. And obviously, this is, we're making the choices a little bit simple here. We know that in reality, fire management is much more complex, but this is just kind of
Right. I have to kind of say that I've never done polls for a webinar before, and I'm not sure I made the complete mark with my questions. So there might be some room for improvement next time.
Okay, so we'll just share the results. And perhaps not surprisingly, there's a strong support for the need for prescribed fire as a tool at 63%. 27% allow some fires to burn to restore the role of fires, and 10% folks suggesting fire suppression is essential to protect communities. I also just wanted to pass on a comment that that someone provided from the previous poll, that they sort of objected to the way it was done, but I think the point is that BC is not one place with a single fire regime, so there's one answer, and what we do to manage fires should depend on the fire regime, ecosystems, values, other risk, and other landscape objectives.
I completely agree. When I first put this webinar together, my assumption was that we were talking specifically about interior BC, but even within that, I agree that there are a lot of different management strategies. When I spoke about the fuel treatment effectiveness research, one of the things that I didn't mention is that the thinning and prescribed burning work is really appropriate, I think, for Douglas fir and ponderosa pine dominated low elevation forests. I have not seen any evidence that it would be effective in higher elevations or more northern latitude forests that are dominated by thin bark species. So we need to talk about building resilience in those ecosystems very differently than the active forest management that we could do in the lower elevation types. So I appreciate that response. So in the continuing saga of all the wildfires we've had in our backyard, here's Winthrop again, and this is just kind of zooming into the Okanogan Complex fires that happened just one summer after the Carlton Complex fires. Again, just incredibly difficult fires for our community to weather. We're still actually in active recovery from these events. The one kind of interesting thing that I've noted is that you'll see that the 2006 tripod complex was a barrier to these fires. And so this area in the middle here was the only area where firefighters didn't need to have a direct response. They, from kind of some fuels modeling, recognized that those areas were not going to need any response. They had some air monitoring of them, but sure enough, that area was a barrier. So given that, the tripod was a barrier, the previous Farewell and Isabel fires were barriers, that really motivated a study for us of, wow, we are getting kind of this mosaic of some resilience, but these are huge fires bumping into one another. We happen to know that there are a lot of fires that have been put out in the last 60 years or more. In our community, the North Cascades Smoke Jumpers base started in 1940, and that's where we have really good records of where fires have been actively suppressed. So we dug through these records, and within just the tripod landscape alone, within the kind of perimeters of the tripod, there were over 300 active fire starts that were successfully suppressed by this local firefighting force. And so the question for this research project was, what if even a small portion of those, or a portion of those, had been allowed to burn? What sort of mosaic would we have had from those events? So we actually created, this was difficult and I'm going to go through it pretty quickly, but we created a series of modeling tools that would allow us to start reconstructing how these fires might have bumped into one another, starting with 1940 and then moving to right before the tripod complex in 2006. And so our modeling system was, we had to create some state and transition models for both low elevation and high elevation forests in our system to grow fuels over time and have stands kind of change in structure and fuels accumulate over time after fire. So that was our state and transition model. And then we needed a way to kind of represent a 1940s realistic landscape. I'll get into that just briefly. And then we used, there's the Wildland Fire Decision Support System within the United States, and we used their fire spread model, FS Pro, in order to burn these known ignitions. And then after ignition, we needed to update those pixels to represent post-burn. And we didn't just say that they were all stand replacing fires. We actually used the flame lengths predicted from the ignitions, the burned ignitions, to map to a low severity, moderate severity, and high severity fire. And so starting with, say, 1940 in the tripod landscape, we did each fire, burned them, and updated these pixels. And if there were multiple fires in that season, we'd burn them all. And then we'd time step forward to 1941 and repeat the process. And these burned pixels interact with fire very differently than the mature forest. So we were really exploring how fire, upon fire, ends up being a feedback. So we had 4 different scenarios that we wanted to explore. The first is unrealistic. We can never actually achieve this, which is a complete absence of fire, but we wanted to have a grow out scenario just to compare to. And then our second scenario is what we call kind of business as usual scenario. So looking at modern suppression, where oftentimes all the fires are actively suppressed, and only the fires that escaped suppression on those hot, dry, windy, middle of summer days are allowed to burn. And then partial suppression is basically, again, we can't actually control the midsummer escaped wildfires, but so those might happen, but we also allow for some late summer and fall fires to burn. So that's kind of our prescription is that at the end of the year, at the end of the fire season, we're allowing these fires to burn. And then finally, a no suppression scenario. So the base landscape development was so interesting for us to do, and I don't have time to get into it, and maybe you wouldn't be as interested in me, but we ran our simulation modeling using historic or lightning density data to model out fire for over 1,300 years. And this is kind of a result of many, many different simulations showing a mosaic of kind of a fire-maintained mosaic in the tripod landscape. And I'll just kind of take a tour of these different colors. The darker colors tend to be older forests. So the green, dark green is young forests that are around 150 years old, 100 to 150 years old. And then the old forests are actually older than 200 years old for this landscape. And then the lighter colors tend to be younger. So we have actually the pink shows post-fire stand initiation, so the trees are just getting established there. Light yellow is stem exclusion open canopy, so these are kind of open stands of very young trees. Dark yellow is stem exclusion closed canopies, so these are pole-sized trees that are pretty young. Understory reinitiation is where the forests are starting to mature and some trees are starting to grow in the understory. And then the other color that we have here that's kind of hard to see in this landscape is a old forest single story where it would be a fire-maintained savanna. There is some of that in this landscape. It's just kind of so pixelated. So I'm just going to show that a lot of this landscape is kind of highly pixelated. We have some areas that burned more as a big patch, like this understory reinitiation probably came in from a large fire. But overall, we have a very patchy landscape. When we've spoken with some fire managers, they would actually have loved to inherit this landscape because it has a lot of different habitat to it and might be more fire resilient, but I'm getting ahead of myself. And so we actually calibrated the 1940s landscape to known aerial photo records for this area so that we used a landscape that really pretty much represented what we know of the tripod area from 1930s to 1950s aerial photo interpretation. So we felt like it was a pretty good start for our simulation. Not exact, but a start. And then here are some of the simulation results. So in the complete absence of fire, all that patchiness, all that kind of mosaic has now shifted to the older forest. So we have dark green as the 100 to 150-year-old forest, young forest multi-story, and then the blue is old forest multi-story. What's interesting about this complete absence of fire is that this scenario best represents the 2005 pre-tripod landscape. So we're really having a fire-excluded landscape prior to the tripod. The second one is a little bit confusing to describe. This would be the full suppression scenario. So we've run that scenario through 1940 to 2005. And in the case of our model run, some of the fire years that didn't actually burn the tripod did within these simulation runs. We ran these 25 times, so 1940 to 2005, 25 times, with a little difference in how wind is delivered to the system for some stochasticity. And what this shows is that at our kind of lower elevations, ponderosa pine, Douglas fir forest, in the south and western part of this landscape, we did get some fires with our simulation results, whereas at the higher elevations, these are more of the Engelmann spruce, subalpine fir, lodgepole pine forests, fire hadn't gotten to it. So this is just one realization of 25, but in general, our simulation modeling had some of these previous fire years actually deliver fire on the landscape. The partial suppression scenario shows the result of actually allowing not only those kind of mid-season fires that escape suppression, but also the late-season fires to do some work. And this is where we're starting to get into some interesting mosaic. You'll see in this middle elevation section, this would be in the lodgepole pine, Engelmann spruce, subalpine forest, that we're getting a kind of mosaic of young forest and maturing forest, the young forest multi-story, in smaller patchworks. And then down towards Winthrop at the lower elevations, ponderosa pine, Douglas fir systems, a lot of pixelation, except for check out this little kind of island of old forest here. In our 25 simulations of the partial suppression, this was often a feature, and it was actually because there's a mountain cirque here, and so this ended up being a little bit of a fire refugia. We had some others as well, where fire just didn't enter in some of the little cirques in these landscapes. At the highest elevations, well, actually up in the wilderness area here, and again, this is Engelmann spruce, subalpine fir, and lodgepole pine, we did get some big blowout fires too, and so this shows the black is post-fire bare ground in that area in this particular rendition. And then finally, our no suppression scenario was our let it burn, so let all fires that occurred from 1940 to 2005 to burn. I'm not sure this is ideal. We're actually going to redo this scenario. We realized after that we got done with our first iteration of these simulations that we'd allowed all of the human kind of the fire escapes from campfires, et cetera, to burn as well. And I think what it shows is a lot of pixelation for sure, but a lot of areas of young forest. And so we're interested in this because about 50% of Washington state ignitions are from escaped wildfires that humans start. And so this might show that there's a tipping point of maybe too much fire is what we're going to explore. So how do these results kind of matter? Why are we doing this? Well, one of the reasons is that North Central Washington is home to some of the last remaining good Canada lynx habitat in the United States, at least the 48 states, coterminous United States. And a lot of that area is burned. So this is showing a burned area reflectance compilation map of fires that have burned in 1990 to 2017. The green is actually suitable lynx habitat, and you'll see that a lot of suitable lynx habitat has burned in the last 20 years or so. We crosswalked our results to suitable lynx habitat. So we were able to crosswalk those kind of forest and successional classes, such as young forest multi-story, old forest multi-story, to what lynx would use. And in our full suppression scenario, we definitely had better lynx habitat, so denning and forage habitat, than the partial suppression. But as we've been working with the lynx biologist on these results, we're actually feeling like that these results, although preliminary, are showing managers that we might actually need to lose a little habitat to have it be a little more sustainable. So less boom and bust, as in the full suppression scenario here. Great for now, but it actually mostly got burned up in the tripod fire event. Okay. So with that, I know that that was kind of a quick tour of our simulation modeling results, and I tried to go quickly on it. I'm going to stay longer after the 10 o'clock hour ends if people had some more questions or wanted to delve into that a little bit more. So I wanted to move into our final study, and this one's ongoing. This is looking at how fuel reduction treatments, in particular prescribed burning, can assist with both a firefighting response and building some community resilience. And in this photo, it's actually showing an area just north of the Colville Indian Reservation. And we have Todd Cam, the manager for Tonasket Ranger District for the Forest Service, talking with Lonnie Costin, who is the fire and fuels manager for the Colville tribes, talking about an interface area where the Tonasket Ranger District of the Forest Service did a lot of thinning and burning with the idea that they might actually get a wildfire coming from the reservation onto their lands. And this area was actually prescribed burned in advance of summer wildfire. And I think everyone's really pleased with the response. So the forest managers were able to do a really light prescribed burn in an area that had just been prescribed burned. And then they had blackened area in advance of the wildfire. And that really saved a lot of the Tonasket Ranger District. So we're building those kind of lessons learned to hopefully have more of these opportunities for firefighters to use. So this is an ongoing study funded by our U.S. Joint Fire Science Program, and we're focused mostly on the 2014 Carlton Complex and then the many, many different fires that we had in the summer of 2015 as well. The project was motivated because the U.S. is engaged in a national cohesive wildland fire management strategy. The Forest Service started this, but other agencies and definitely tribal groups and private landowners are coming together under the collective motto, all hands, all lands. And so the first stool of this kind of, or first leg of this kind of stool is to restore and maintain fire-adapted landscapes. So my previous 3 lessons learned really addressed that. And now we're really working on, through a lot of research studies, how to build and maintain fire-adapted communities. And then the third stool, leg of the stool is really important to me. We've lost some local firefighters and I get choked up about it. So how do we actually build some resilience on these landscapes so that there's a safe place for firefighters to do their important work? So this is kind of a boring flow diagram, but basically we are doing a treatment, like influence on fire behavior. Part of it, we're actually looking at past fuel treatments and how they influenced fire spread. And then we're doing a lot of interviews with fire managers who actually worked these fires to understand how they made use of these fuel treatment areas, kind of lessons learned. And what we're hoping to do is actually create for North Central Washington a way to actually model more and more fuel treatments on these fire-prone landscapes to know where we have a threshold of effectiveness. And so that's the end goal of our project. And again, we're going to be using our same simulation modeling tool, but this time not just be modeling past fires, but also past fuel treatments such as thinning and prescribed burning. So on to this. What we've learned so far from this study is encouraging. So coming from the Carlton Complex, I'm just about to publish these results. Where past treatments were placed, really mattered. One of the fire management topics that we've been discussing with managers is kind of lessons learned is that we should probably explore some more catcher's mitts. So this is one of the concepts that I think I can illustrate with the Carlton Complex that wasn't intended this way, but it worked as a catcher's mitt. So I'll review that the Carlton Complex burned mostly in a single day, July 17th, 2014. It was very directional with fire starting here and wind driving it through here, and if treatment in the wake of the fire, in kind of the heat of the fire, didn't fare very well. But this treatment right here is a very large 1,000+ hectare prescribed thin and prescribed burn. And the area that was hit by kind of a head fire from the Carlton Complex didn't work well, but at a topographic break where the fire was flanking and burning downhill, this was not only effective for this treatment unit, but also because there were a network of treatment units, this ended up being kind of an unintentional catcher's mitt. And this area in the center, we call the donut of the fire, didn't burn. Fire management was able to get in here after the big spread date and do some more suppression activity. So we're thinking about this catcher's mitt idea and where strategically we can place treatments to hopefully weather a fire event and leave more area unburned. So we know that the Carlton Complex, for example, burned with very predictable summer winds. And so we're hoping to use those kind of predictable winds, not that it will always work out that way, but to kind of hedge our bets with some treatment placement. So here's just a picture of Carlton Complex, and one of the kind of phenomenal things we saw from some of the nighttime images, huge amount of ember transfer with the winds and smoke plume. And these fires literally actually jumped ridge to ridge. And so there were some leeward slopes that were sheltered from this rapid fire spread that ended up being not as intensely burned. And those might be really good opportunities to put some treatments in advance of summer wildfire seasons in the future. So just to conclude, I wanted to leave some time for questions. I'm hopeful. I know these are some wicked problems and wicked times we're living through in terms of wildfire, but we're finding that field treatments do work and it's worth the investment. Fire is contagious, and so at low elevations, we can use prescribed burns to kind of reduce the continuity of fuels. At higher elevations where it's not appropriate to do thinning necessarily, we might need to look at actually using wildfires or planned ignitions to create some mosaics to break up those landscapes. And this is kind of an interesting topic that I'm starting to explore is that forests might, in this lens, be viewed as stores of potential energy. And so I'm thinking a lot lately about how we want late successional habitat for a number of wildlife species, but we also at the same time need to recognize that sometimes that late successional habitat is an energy store, and how efficiently we store that across landscapes has big implications for how resilient those habitats are in the future. And so I think that mosaics are kind of an answer to creating more resilience on landscapes, and they have some big implications for wildlife habitat as well. So here's a little sobering lesson from our national forest that I live amongst. Wildfires are doing all the work right now, a lot of the work. So these are cumulative prescribed burns, RX fire versus wildfires, and you can see that wildfires are doing the lion's share of work. I'm not sure they're doing the work we want right now, and so I'm really hoping that over time with some active fuels management and maybe even use of late season wildfires, we can start kind of turning this dial and having the wildfires not be so destructive. All right, I'm going to end with this picture of Arrowleaf balsamroot. It's a reminder for me to point out that a lot of plant species in our area are really resilient to wildfire. This individual plant actually got burned over in the Carlton Complex fire in that summer of 2014. And then we had some pretty big rains in September, and this individual opted to resprout and reflower that fall, just kind of showing that it's built to last fire. And so as we kind of move forward with more fire, we're working with some species that are adapted to frequent fire in some cases, and that's hopeful. All right, these are my acknowledgements, and I'll just end with a little contact information. Thanks.
Thanks very much, Susan. A great presentation, and thanks for sharing all the lessons learned from your work. So we do have a little bit of time for questions. As Susan said, we'll plan to go a bit past 10 for those that want to continue with the Q&A. Others who have other things to do, feel free to leave whenever you need to. Our first question is around the fire simulation exercise in the tripod fire. Is how do you determine how long the historically suppressed fires would burn for? I mean, he's saying how many of these fires could have been mega fires too.
All right, and so we found that through our simulation modeling that the tripod was an outlier event, that from 1940 to 2005, using historical weather, not many of those fires would have ever hit the size of the tripod fire. So even in the middle of the summer, I hope that answers the question.
Okay. A comment that all the lessons ring true and align with my experience in the BC Interior. Question how the cost to do proper fuel treatment in all the areas needed is staggering. How will we, I guess the big we, society, pay for this?
That's such a good question. Was there more? Did I cut you off?
No, that's the question.
Okay. Well, I think we need to be honest about some of the costs that we're already incurring from wildfires, and we're spending a lot on wildfire suppression, and I think we're going to have to think about some active getting ahead of these wildfires for eventual mitigation of those costs. That's a hard thing because, as you've seen from my presentation, we're hedging our bets with field treatments. Not every single one of them will work, but more and more, I think we're going to get to some cost-benefit analyses that will justify upfront investment because we're already spending a huge amount on fighting these fires and recovering from these fires.
Okay, great. Another person's asking about the software you've used, the FS Pro. Does it require a license? And if so, do you know the cost of it?
Oh, no, it's actually free. And I'd be happy to have that participant get in contact with us. We are using a command line version of the tool for our scripting process, and I'm sure we can share that. The Wildland Fire Decision Support System is more of a login required system, and I think users can be granted kind of view privileges, but it's mostly for the fire managers of the U.S. So we're not actually using that system. We're using a command line version of the tool.
Okay, great. Thanks for offering to follow up. That's super.
Of course.
Another question around the balance here is how do you strike an educational balance between the aspect that fire is useful, yet prevention still necessary, and it's not okay to toss cigarette butts out the window?
You know, I'm really inspired by traditional fire knowledge. Had I had more time, I would have really liked to talk about First Nations burning and the landscapes that they maintained. And I feel like that's an important concept in that we need to think about fire as an ecological process and that we can be part of that process. So people have lived within these landscapes for millennia and reduced fuel and used fire as a tool. I think we have a lot to learn from that approach. It comes with smoke, which is awful, but I think that over time, as we move forward, there's going to be a balance of using fire to fight fire well in advance of the fire, not just during the fire season.
Do you have any comments on how your conclusions reflect on more climate-limited forest ecosystems, e.g. coastal western hemlock or transition areas?
Right. I feel like from some of the feedback, it's very deserved that I should have actually specified a little bit more on my landscape and what's appropriate for where I live. We're talking quite a bit about fire now becoming a lot more frequent in Western Washington and the Coast Range, Canada, BC. I still don't feel like what I described in terms of thinning all the understory fuels is completely appropriate for Western forests because they do have habitat features that are very different. And so I want to be careful to say that there will be more fire in the West Cascades and the Coast Range, and we'll really need to start tailoring fuels management decisions specific to those ecosystems. So.
Great. And I think you touched on this earlier, but someone's asking about whether you've conducted any cost-benefit analysis.
We're doing a little bit. It was actually expressed within our project plan for that fire mosaics simulation study. We haven't gotten to the point of actual numbers. We've been more doing the cost-benefit analysis for key species such as lynx, and then also doing kind of a carbon trade-off analysis, looking at carbon carrying capacity. I'd like to delve back into the economics of it. We're not there yet. We're supposed to be.
Okay, good to know. Thank you. Another person's wondering about some of the software in addition to FS Pro. Which fire behavior and stand dynamics models do you find the most helpful for simulating fuel treatment effectiveness and to guide placing landscape scale treatments? How can we integrate fuel model types developed in the US and Canada to remove the arbitrary border in our modeling exercise?
Oh, I'd love to. So we have this tool, mapping tool called Wildfire, and I would really like for Wildfire to remove that artificial border and start using remotely sensed imagery to map fuels in Canada as well. Right now, a lot of our fire prediction systems rely on the fire behavior fuel models. I'm not a huge fan of them, honestly, but we are assigning fire behavior fuel models to predict surface fire, and then we're assigning canopy characteristics to predict the crown fire part of it. So I would say that our tools right now are a little rudimentary. They seem to be effective at looking at these kind of mosaics and how they evolve over time, but I'm also involved, if people are interested in kind of following up on this, in a new set of tools that are using computational fluid dynamics models to predict fire spread. I think that's going to take off in the next 10 years and be pretty exciting because they're just better tools, and we'll be able to make use of some LiDAR and other new remote sensing technologies to kind of more accurately map fuels. So a lot more there, but yeah, I think that's the short answer.
Great. Does Washington State have regulations for managing privately owned forest areas in terms of some of these issues?
Definitely, yes. I'm wondering if that question has to do with also allowing for some prescribed burning. I'm not sure.
I think that's probably what it's related to, yeah.
Not just the regulation. So,
yeah, given the tool.
So far, a lot of private landowners are just doing pile burning, and if they're large projects, they'll need to apply for smoke permits and burn on good ventilation days. There are some cases increasingly on larger ranch lands and then some forest lands where private landowners are starting to do broadcast burning, so larger kind of landscape burns, coordinated sometimes with the Department of Natural Resources, but especially the Forest Service. So where there's private lands adjacent to the Forest Service is starting to partner with those private landowners to get the burns done. We also have a new, relatively new in the last 10 years, Washington State Prescribed Fire Council, whose mission is to really promote prescribed fire policy at the state level.
Okay. Why do you think the thin and pile burn fuel treatments were so ineffective?
They're not always ineffective. And so I looked at those records, and it turned out that a lot of those treatment units happen to be older. And so I should have mentioned that in the slide, that it didn't give thinning and pile burning as fair of a shot as it should. There have been studies that have shown that the fire severity in thin and pile burn units is comparable to thin and what we would call underburn, where a fire is run through the entire understory of a forest. However, I do think that it really depends on the type of pile burning. If you're just burning machine piles, at landings, then I think that that would be comparable to just having a thin-only unit. If you're doing really intensive hand piling, it might be effective.
Okay. Did the simulation also include historic weather and wind conditions?
Yes, and I really did have to step through that very quickly, but we're excited because we had the known fire start locations, and then we were able to actually go back in time and use the historical weather for those fire starts. There's still some guesswork involved for sure, but we tried our best.
Okay. Someone's also wondering about if there's a list of your papers that you or others have published on this work, or maybe a link that we
I'd be
could share.
happy to. Yeah, actually we have a final report for our fire simulation modeling, but I will also, what I can do is just send a follow-up email with a list of papers that really represent all these kind of lessons learned today. Be happy to do that.
Okay. I think we might have time for one or two more questions, and then we'll probably wrap things up. I know there still may be some more here that we haven't gotten to. Someone asked about whether you've incorporated spread direction in your modeling when the daily direction of spread can be so variable, or how you've done that, I guess, is the question.
Right. So FS Pro is a fire spread model that incorporates a digital elevation model as well as wind direction and intensity. And so fire spread is really tricky because it's not necessarily just a wind-driven fire spread, but FS Pro will respond to terrain features as well. I think that that's probably getting at the answer.
Yeah, okay, great. Do you suspect that fuel management is causing treated fuels to become drier and hence more hazardous?
I love that question. There are so many trade-offs when we actually start looking into fuel treatments. The picture that I actually have right up in front is a good example of a forest being a lot more exposed to solar radiation and wind. And so, yes, you would imagine that compared to a closed canopy forest, the fuels would dry out sooner in the spring and be more available to burning. So I think that that's another root concern I have about using thinning only as approach to fuels reduction. It can certainly reduce the canopy fuels, but it actually can worsen the surface fuel condition in a variety of ways. That's why I think prescribed burning is so important as a follow-up treatment.
Well, thank you very much, Susan, for your great presentation and for answering many questions that people had. We appreciate you taking the time to share that information, and I'm sure there's lots of information here that's applicable to many of the ecosystems in the interior of BC. So thank you very much, and hope that everyone has a great day.
Okay, take care.
Take care.